Hey everyone, we're going to continue in 6.1 Theory C. And you heard me saying that we're not working with degrees yet, right? And fortunately, or unfortunately, you can say, in most practical things that you will see, we work with degrees. So it's maybe rather strange to see that we've only discussed inclines and grades up until now. And remember, inclines are a ratio and grades are a percentage of that incline. So normally we work with angles and degrees, right? Let's take a look at that right now. And I'm going to introduce you to something like this first, and then I will say how this will work for degrees. Let's say you have a right angle triangle like this with sides 2 and degree being 45. So here the angle is given in degrees. I can calculate the incline here, right, by still just doing rise divided by run, which will give me 2 divided by 2, gives me an incline of 1. Rather steep, you can say. Well, if I'm going to enlarge this triangle, then the angle stays the same, remember chapter 2, but my sides stay the same as well. Well, they don't stay the same. I mean, 2 is not the same as 4, but the ratio stays the same. The rise divided by the run stays the same. If I do rise divided by run, 4 divided by 4, I still find 1. So apparently, what I can now conclude from this is that if the incline of an angle of 45 degrees is 1, then the incline and the angles are kind of independent of the run, right? I can now try to convert between an incline and an angle. And for that, I don't then have to use the other information. And your calculator can do that for you. We can do that by taking a so-called tangent of something. And in Dutch, we call that the tangens. So let's see what the book discusses here. For an angle of elevation of 31 degrees, well, I took 45 degrees, but let's say 31 degrees, rise divided by run is approximately 0.6, independent of the run. Therefore, the incline of an angle of 31 degrees is 0.6. Was here the same case, right? The incline of an angle of 45 is 1. Doesn't matter how big or small the actual triangle is. But instead of saying the incline of 31 degrees is approximately 0.6, we often say the tangent of 31 degrees is approximately 0.6. And we notate it like this. We abbreviate tangent to tan, and then we say tan 31 degrees is approximately 0.6. So this tangent kind of let us switch or convert between inclines and degrees, you can say. And what they now say, this formula, the tangents of the angle of elevation equals rise divided by run. Later in the chapter we will discuss this formula in a different context and we will change some things around. But for now, what they say is in Dutch, de tangens van de hellingshoek, dat is de hoek die eigenlijk bij de helling hoort, is gedeeld door verticaal, gedeeld door horizontaal. What does that mean for us in a practical way? First of all, remember, and I already said that the tangent helps you convert between incline and angle of elevation, you can say, right? So, and it helps you as well if you have something like this. This looks a lot like the examples that you got in Theory B, but then we weren't given an angle of elevation in degrees, but we were given this the grade, for example, or the incline. Now I can still calculate what AC is by using that formula right here. Tan angle of elevation equals rise divided by run. So here, if I want to know AC, which is the rise right, I will now say that tan of 23 degrees equals rise divided by run, which is 700. And just so you know, there is just a tan button on your calculator. Later on in your mathematical career, we also discuss what this 10 key actually does a bit more in depth. But for now, just use the key and you will see what will happen. Be sure that your calculator is on degrees, right? It can be on degrees, rod, or grad. And rod means radials. We will discuss that in, I don't actually know, I think 4th or 5th grade if you choose mathematics B. And grad, I don't know, but I guess they mean gradients with that. Just keep it on degrees for now. And normally all your calculators are already set to degrees. Hey, if we have this, we can now calculate AC. The variable x AC is the same to the tangents, or the tangents I should say in English, of 23 times 700. Just type this in your calculator, 700 times 1023, and you get your answer, which is approximately 279 meters. Okay, so what actually changes here is that instead of saying incline equals rise divided by run, we now have tangent equals, and then tangent angle of elevation equals rise divided by run. And here is a short overview of this, what you should know, what the incline is, what the grade is, what the angle of elevation is, and how to work with them given some information. And then the grade, normally you immediately first convert to incline, right? Okay, so be on the lookout if you are given angles in degrees or if they give you an incline over grades. Good luck.